example number 6, they ask us to verify f and f inverse. Well, here's what I want you to know. If I have a function and I take the composite function of the inverse, that should equal, if they are truly inverses of one another, that should equal the inverse composite of the function, which always reduces down to just x. And where that comes from is that if we start with an x value and we plug it in to f, and that gives us a value which is y, okay? And then my inverse function, which we'll call f inverse, or let's just name it a different number or letter, g. If I plug something in and the inverse undoes what's being done, then I should just be left with whatever the original x value was. So let's do that. Let's try that. So if I let f be, let's pick two equations. F equals x cubed plus 1, and g of x, which should be the inverse, is the cube root of x minus 1. So those should be inverses. Now let's plug a number in so you guys can see how that works. If I say that x is equal to 1, and I plug that into my function, which would be 1 cubed plus 1, what does 1 cubed plus 1 equal? 2, right? Now, if I take that 2 and plug it into this function, which is the cube root of 2 minus 1, what's 2 minus 1? 1. What's the cube root of 1? That's no accident. So I started here, did some math to it, got this. If I take that same value and plug it into the inverse, I should get right back to where I started. The inverse undoes what was being done. Does that make sense? You say, oh, Mr. Adams, I want to believe, but I'm lacking faith. Help my unbelief. Let's do another value. X equals 0. Plug that into the function x cubed plus 1, so I get 0 cubed plus 1. That spits out a y value of 1. Now, before I even plug this in, what do we expect my y value to be? 0. Because the inverse undoes what was done to 0 mathematically. In other words, I had 0, plugged it in, I did some math to it, and the inverse undoes what's being done. So if I plug this into this equation and I take the cube root of 0 minus 1, uh-oh. Oh, it's not, I don't plug in 0, I plug in 1. See, Mr. Adams almost scoofed up. Right? Because I got to plug in this value. So what's 1 minus 1? 0. What's the cube root of 0? 0. So now how do I verify that algebraically? So whatever I plug in for x, I get x. That's where this comes from. Now, does it matter where I start? No, I could start here, plug in a value, and have it come back. Either way, it's going to end up with x. So now how do I verify that algebraically in generalized terms? Well, let's just write them down. So one way I could do that is I could take f of g of x now that you guys are experts in composite functions, we know that this will be, what do I plug in those parentheses? G of x. Well, what's g of x? Well, g of x is the cube root of x minus 1. So I'm going to take the cube root of x minus 1 and cube it, and then add 1 to it. So now when you cube a cube root, what do? They cancel each other out. So in the next line I've got x minus 1 plus 1. So f of g of x is equal to x minus 1 plus 1. What happens with my 1's? Cancel, and what am I left with? X. That's no accident. Now, you got to check it both ways. Just because you get an x here doesn't mean you'll get it if you do it the other way. In other words, what I got to do is now I've got to do g of f. So to do g of f, I'm going to start with g of x, which is supposed to be the inverse. So I say g of something, which is the cube root of something minus 1. Well, we're going to plug in f of x for the somethings. So in my next line, I'm going to get g of, what was f of x? X cubed plus 1. And then we're going to take the cube root of x cubed plus 1 minus 1. Well, g of f of x, which is what we're really solving, it reduces down to the cube root of x cubed plus 1 minus 1. Those cancel each other out, so I get g of f of x is equal to the cube root of x cubed, which is really x to the 3 over 3, or just plain old x. That's no accident. It'll happen that way every time if they are inverses of one another. Does that make sense?